Well, hello. I am Dr. Tom Walla, and I'm here today to do correlation and and maybe a little bit of regression. We'll see how far we get today. So what we're going to do is use Excel. Because we're doing this on only Excel without using external programs. Let's get right down to it. This is the data here. I'm showing you my Excel screen. That's the data that we were using. I sort of made this data up. It's really nice data though. And I wanted to paste it in here and take a look at how to analyze it. So remember, and you'll see on the screen here in the middle, I have that we're going to be calculating what is called the correlation coefficient, also called the Pearson product moment correlation coefficient. And so it's really pretty straightforward though. It's this equation that's on here. Now, hopefully you've already seen the other videos, so you know what the equation is. I'm just going to show you how to calculate it. And the first thing I'm going to do is I'm going to break apart my data here into two pieces of data that are a little further apart. So I've got some room to work here. So this is my X variable on this side, and this is my Y variable on this side. So each of these 2 points, so the 10 and the 5, correspond to a single data point, right? So these are essentially coordinates for each of the 25 data points that make up this database. To do the analysis, I've written on here that we're going to need deviations from the mean for X and for Y. So that's a little bit awkward. There's no formula for that I know of. So I'm going to go to the bottom. Actually, I'm going to need space to label things. So I make some space. I'm going to calculate the mean here. And the mean is going to be equal to the average. We've done this before, no problem. Of course, I misspelled average, so the average of these guys, okie doke, there we go. The average is going to be these. This is the average of X, right? And then over here, I can put equals the average of the Y's. It looks like I've got a little extra space on my screen today. I'm going to try to make it a little bit larger for you so that you can see it better. Let's go to 125 maybe. I don't think that helped. I'm going to have to stay at about 110, I think. Let's try 110. That helps. Okay. So now as we're looking at it, we can see that we've got the means. And then you've done this before, so all we have to do is subtract that value from the mean. So this is going to equal this X value minus, and I'm going to subtract the mean value at the bottom. Now, I'm going to drag this down, and I want the mean value to stay the same, like to be the same cell. So I'm going to $sign that cell. It'll be exactly the same cell every time. And then I'll hit return, and I'm going to drag it down. So you see that one, all right? And I'm going to do the same thing over here. I'm going to put equals whatever's in that cell minus the mean value, but I don't want the mean value to change, so I'm going to $sign it. There, and I drag that down. So that's a bunch of information that we needed. Need a little more space here, so I'm going to move this over. Now, I'm going to label these the deviations. And this is the deviations as well. Okay, and then on this column, I'm going to go ahead and do deviation squared. All right, so let's do the deviation squared in this column. So this is quite easy, equals whatever was in that. And I'm going to do raised to the power of 2, which is the caret and the 2. And that can be easily dragged down. And those are all the deviations squared. And this column, I'm going to do equal whatever the deviation is, caret up 2, square it. And then we're dragging that one down. So that's good. We got deviation squared. Now, if what we need for this, we have the deviations of X and Y. So we're actually ready to calculate sum of squares for X, Y. I'm also going to check to see that we need sum of squares of X, which is the sum of squared deviations for X. And that is simply the sum of all the square deviations. That was pretty easy. So we've got that. We can also put it here equals the sum of all the squared deviations. So that is SSX and that is SXY. Now you could alternatively do what's called deviation squared, which is a formula in Excel that actually does DEVS. You can see it come up, deviation squared. It actually asks for it'll give you the deviation squared of all of the original data points right there, all right? So that is kind of nice. So I can do it on this side too. I like to show you the shortcuts. The problem is that we needed to make the deviations anyway if we were going to be able to do the cross product. So we needed those. And there's no cross product command as far as I can find in here. Oh. Yeah, let's go back and fix my equation. Equals sum of those. Okay, whoops. Didn't put in the formula DEVSQ. Looks good. So those numbers match up exactly. So I know what I'm doing, I guess. So the next thing we're going to do is we know that we need our SSXY. So let's just go right over here and see if we can calculate it somewhere in this area. That's so you can see it. I probably wouldn't put it here. SSXY is going to be equal to, this is a curious thing. It's going to, oh, I know what we have to do. We have to multiply what's in this column deviation times that deviation. So I'm not ready to do it yet, and I can't put it here. So what I'm going to do is right over here, I'm going to put SSXY, all right? And this is going to be the deviation of X times the deviation of the Y. Right, and so instead of squaring, we're just multiplying the X deviation times the Y deviation. So that means it's going to be that deviation, asterisk, this deviation. And that was pretty great. So I'm going to drag that down, and that goes to here. Now I have to sum those together. I always like to be able to label my cells, so I'm a little bit worried about that, but I'll just go ahead and put equals sum there, and I'll have to just tolerate that this particular example is a little bit sloppy because this is SSXY, right? That's what that is. That's called the cross product, okay? And we know we have SSX and we have SXY. So for calculating R, I need this value on the top, and then I'm going to have to use the sum of squareds of X on the bottom. So that's, I'm going to move everything down here. So I'm going to put SSXY over here. I am not going to redo this video just because my numbers don't fit. So I'm going to put them there. And then I'm going to say SS of X, we've already got, right? So on the bottom, we're going to put SS of X times SS of Y, right? And that's going to go here. So that's going to be equal to the sum of squareds of X, which is that number, times the sum of squared of Y, which is that number, right? And now I'm going to square root them, SQRT. So that equals the SQRT square root of that number there. So there I've got a really big number, and that looks good. So what I'm going to end up with is a ratio of this number over that number, right? So because that's what this says up here, it says that's the equation, no problem. So right now I'm going to finish that. I'm going to put right here, R is going to be equal to this number divided by this number, 0.875. And thank you for watching the whole show. It was really pretty straightforward. We will look up the significance of this in a test. For those of you that wonder if there isn't an easier way, there is an easier way. I'll show it to you now. You could use a term called Pearson. It's a function in Excel. Pearson returns the Pearson product moment correlation coefficient, which is exactly what we just did, and it asked for the two arrays. So it would say put in the first array, which is this piece of data here, and then you would hit comma, and then it would say put in the second array, and then you would put into parentheses and hit that, and it would give you the number. Ha! So if you didn't spend all day looking how this works, you could just hit that number. There's also another function called Correl, also called correlate for short. And Correl also takes in two arrays. Let me guess. The first array is your data. And comma. And the second array is the other half of your data. I find this pretty hysterical. So if you want, oh, too many arguments. Let's see, oh, did I typo something? What they meant was that I put in an extra comma. You can do that. So this is the result of Pearson, and this is the result of Correl, or correlate. And this is the homemade jam. Okay, that's the good stuff. We made that at home. So maybe it's better. Thanks for tuning in.